Okay. So this is My3DTrains.com, which, unless anyone knows otherwise, I think is the first 3D New York City subway map and trip planner. So I just got this deployed online. I've been working on it for a long time, but as you can see, there's this 3D map and then all the stations of the subway. It's a little needs a little bit more work, but it's mostly there. But I just wanted to test it out now. If anyone wants to name a subway trip with one transfer or less, and then we can see how it works and maybe compare it to Google Maps and see if it comes up with the same information. Does anyone want to do a subway trip?
191st on the 1 to J Street Metro Tech.
All right, so 191st on the 1. And so there are two ways to enter a start 191st. Two ways to enter the stations into a trip. The first is you can click on a station and it comes up with the arrivals for the platform. And then you can set that as the origin. And then J Street Metro Tech. Which platform would you normally, which one would it be? Probably let's see if the R works. Maybe. Okay, that one worked. All right, cool. So you get the information, a little more detail over on the left, but here it looks like we're transferring at 168. The transfer will be 3 minutes long. You go to the downtown A, and then it highlights all the stations that you'll be going to, and that arrives at 7:25. That one leaves at 7:43, so we'd probably take a later train, but you can switch to like the next train by clicking on that. But yeah, that's my app. That's what it does. And now I'm going to show you how I made it. All right, so this is building a subway app in 3D, the My3DTrains.com story. All right, so the core of my app is the MTA's real-time subway feeds APIs. As you can see, there are 8 of them, and each API endpoint corresponds to a different route or routes within the subway system. They provide you with GTFS data, which is General Transit Feed Specification. It's a standardized format that transit agencies use to share their data with developers. And this is what the GTFS data looks like. So this is just a small part of it. This is like one train and part of the schedule of that train. But normally you'd get a bunch of trains and a ton of these stop time updates, which is the schedule. But basically we're concerned with everything inside of this trip update object here. And basically this trip object corresponds to a train. So that has a trip ID and a route ID. In this case, it's 7. But then the thing that we're using the most in this program is the schedule, the stop time update. And that is an array of stops that shows the schedule and the position of each train. And so you have an arrival time, a departure time, and then you have a GTFS stop ID, and then a platform north or south, which is the direction of the train, which platform will be arriving on. So this is basically what that looks like in a more human readable format. You hit one of those endpoints and you get back a ton of trains, and then every train has a schedule inside of the train. So you got this one I just made up, but it's C, and it stops at Clinton, Washington, and Lafayette, and then Hoyt Schermerhorn, and it's northbound with the arrival and departure times. Okay, so in order to plan a trip with the GTFS data, you need to ask yourself what at its core is a subway trip. And it's when a rider boards a train at the trip's origin in the future. You can't catch a train that's already past your station. So you board it in the future, and then later it stops at the trip's destination. So there's an order to this. It needs to, the platform for the origin of the trip needs to come before the platform at the end of the trip, of course. And then you exit the train and your trip's complete. And so to accomplish this, we filter all that data for trains that serve the start station and the end station in the correct order in the future, and then we sort the list by arrival time. If the filter yields 0 results, then there are no trains traveling between the station, and an error message will get displayed. And we repeat this for multi-leg trips, with the arrival time at the transfer station for the first leg of the trip being before the departure time of the second leg of the trip. And for example, let's say we hit one of those endpoints and we get back a train that does not have the start station in the schedule. We can't board that train, we ignore that. We get one where the end station is before the start station in the schedule. That's moving in the wrong direction. We ignore that one too. This one goes to both stations in the correct order and arrives at the destination in 15 minutes. That's great. We'll append it to the list. Again, this one's moving in the wrong direction. And finally, we have this train that arrives at the destination in 10 minutes. It arrives at the start station before this one, but arrives at the destination faster because it's an express train. So that's why it's important to sort the list. And then, as I mentioned earlier, my program has the limitation of just having one transfer so far. I want to fix that later. But right now, I just want to show you how I determine where that transfer is. And in order to do that, you have to understand the concept of complexes within the MTA. And a complex is a structure that contains multiple stations where you can transfer between stations or platforms without swiping in or out of the system. So Times Square is a complex, Fulton Street's a complex. But transfers between lines usually occur within complexes. And every station has a complex ID. And if multiple stations have the same complex ID, that means they're in the same complex. So this is a little excerpt from my database. And this is how I'm finding where to transfer for a trip. Let's say we're taking a trip from the Astoria Ditmars NW to 59th Street, Columbus Circle 1. What we're going to do is query the database for every station that serves the N or is served by the N and W lines. So we get all of these stations and all of these complex IDs. Then we query the database for every station that is served by the 1 line. And we get a bunch of stations and each with complex IDs. But if a complex ID appears twice in that list, then that means that it is part of, it serves both the start station lines and the end station lines. So there can be a transfer that occurs at that complex. So then what we do is set the destination of the first leg of the trip to the Times Square 42nd Street and RW, and the origin of the second leg of the trip to the Times Square 42nd 123 platform. Cool, so that's how you do a transfer. And that's basically the back end of my program, which I do all in Python, dealing with the GTFS data. But now we're going to get into the 3D element of the program. And to start, I build this map in Blender, which is an awesome open source 3D modeling program. It's really cool, it's really powerful, it's free. I love Blender. And the key here is that when I build my map, and I build these little stations down, these little cubes, I name each cube with the same GTFS stop ID that corresponds to the actual subway stop in the system, and that is provided by the GTFS data on the MTA's API. So every one of these is named with the correct station code. And then in order to make this, we've built a 3D model, but that's just like a static thing. You can't really do anything with it. It looks cool, but it's not interactive yet. And the way we make it interactive is by using 3JS, which is a JavaScript and WebGL library that enables you to render 3D scenes within the browser. It's really cool. I love 3JS. It's not too hard to use. If you know JavaScript, you can learn it pretty quickly. And then on top of that, I'm also using a library called React 3 Fiber, which takes React's sort of component system and adds it to 3JS, which is really important for my program. I'll tell you why in a bit. But basically, in 3JS, a mesh like a cube that you'd see on the screen is a geometry and a material together. The geometry are the points in space, and then the material is the color, the properties of the that are rendered on the screen. Like, you know, it can be green or red or shiny or dull. But then there are also position, rotation, and scale attributes amongst many things. But basically what we're going to do is take a GLTF file, which is a compressed 3D model format that we exported from Blender, and load it into our program using this little loader up here. And then we're going to loop through all of the nodes in the scene graph. The scene graph is all the shapes inside of our 3D model. And because we named everything with that GTFS stop ID naming convention, we can recreate those stations in an interactive form within the program. So we're looping through that Blender model, and we're extracting some of the properties from that model, and then rebuilding these little cubes, the stations, within the 3JS scene. And so we take, I don't know, the name, the materials, the position, rotation, and all of that, and we rebuild these stations from Blender as these interactive station components in our program. So now, if we know the GTFS stop ID, we can access these geometries in our 3D scene and change properties of them. They're able to keep track of their own state now, which is very important. And so to put it all together, a trip is an ordered array of trains, either one or more trains, that we get the GTFS information from, and that train or trains takes us from the origin to the destination, and each train contains a stop schedule. So in this example, we're going from Clinton, Washington C to Grand Central. We take a C train to Fulton Street, and then from Fulton Street, we take a 4 to Grand Central. Each of those trains is going to have all of the stops that the trains stop at in their schedules. So then we loop through all the relevant stops, which are the stops between the origin and the destination. We don't want to include any stops that aren't part of the trip. And then we only render the stops included in the trip on the map. All the other stops disappear, and we only see the stops from our trip. And if the stop is something like the start of the trip, the end of the trip, or a transfer, then we make this little HTML element that gives the user more information. So that's the technical side of the program, but I wanted to also talk about the design side of it. I'd never designed a map before, and it's an interesting design challenge because you have to make something that contains a lot of information without it being too busy. You have to be able to read it. It can't just be like, you know, too overlapping text and everything. And I thought, yeah, and then the features for it, navigation should all be very intuitive. Like, you don't want to have too many things getting in the way of the user using the map. And I thought it was cool. The MTA has sort of been able to balance this, like, what would you call it? Like usability versus style in a really interesting way. They've, even though it's like a huge transit agency and a big bureaucracy, there've been some really cool designs that have come through the MTA over the years. Like, you have this Art Deco subway car. I really like this R68 ad from the 80s. It almost like looks like a rave poster or something. You've got the Massimo Vignelli subway map, which is back. I'm sure you guys have noticed. That's really cool. And then I really liked this pin. This is from 1979 when they changed up the colors of the routes. And like this, we're changing. It's got this kind of like, I don't know, hippie design to it. It's really interesting. But anyway, it's a you know, transit system. It's not an art gallery. So form needs to follow function, but that doesn't mean that it can't be cool looking. And so, like I said, I really liked the MTA's like modernist design, and so I mostly ripped off the MTA for my program. You know, I kept like the yellow, the red, the arrow, Helvetica font, white on black. It works. It's great for conveying a lot of information, so I kept it. I took some liberty with the logo up at the top. I really like early 3D graphics back when computers and game systems were really limited by their processing power. The more polygons you have in a scene, the harder it is for a computer to render things. And so back then you really had to limit the amount of shapes in your scene just because computers or game systems couldn't handle anything too complex. But now they can handle lots of stuff. Even 3JS runs online. It can, render really cool, complex models. But I still like the challenge of making low polygon 3D models. It's just like, what's the minimum amount of shapes that you can use to make a recognizable object? I think that's a fun challenge to work with. And then here's some more design inspiration. We got some photos of the 7 train platform at Grand Central, which I feel like is like the meanest platform in the subway system. It just like, I don't know, it kind of looks like when the Terminator gets his skin ripped off. It's like this like brushed steel. I also really like this turnstile back from when the subway system took tokens. But yeah, the map's a work in progress, but I want to, sort of have this like brutalist aesthetic to it. I think it's really cool. So what's next? Like I mentioned earlier, I want to make a robust pathfinding algorithm that can handle trips with more than one transfer. Most trips are fine with just one transfer or less, but then there's certain weird ones, like if you're going from a G train stop to Astoria, you're going to want to take the 7 train for one stop. So it's like actually quicker to transfer twice usually than to go into Manhattan and do a transfer. But then whatever pathfinding algorithm I make has to deal with lots of different things like reroutes, nighttime schedules, and just like the varying transit times of trains. They're changing all the time. I also want to be able to show the location of trains on the tracks and animate them. Like when you log on, you can see all the trains in the system moving around. I think that'd be really cool. Or when you plan a trip, you can be like, oh, my train's, like 2 stops away, here it comes. Or like, oh, that's pretty far. Like, oh, I'm not going to make it. You can actually see it. I think that'd be really cool. I'd like users to be able to record their commutes and sort of like see on a chart, how long their commutes are taking, if any different like factors affect them. And then I want to add details to the map and finish adding the tracks, which takes forever because of that GTFS stop ID naming convention that I mentioned earlier. And then also I want to get user feedback. What do you guys want out of a subway app? I also wanted to talk about why I built this subway app. I mean, there's plenty of transit apps that already exist that are arguably better than this. But I wanted to make a transit app that's as beautiful as it is useful. I feel like sort of when I was growing up, the internet was a more hospitable, like fun, creative place before the advent of social media, before we all got like drawn into these platforms that kind of monopolized everything. And now I feel like creative people are forced to like get their creativity out within social media through posts and whatnot. And we're forced to make, cheap, plentiful, and often divisive content. Like it's not like a feel good place. It's like, you log on to Reddit and it's like videos of fights and stuff. And it's like, because that's what the algorithm recognizes people pay attention to. And then the other side of that is that consumers scroll through this content and feed their data into big tech. And so this is not a new problem. This is something that's always existed in media in a capitalist society. But I took some screen caps from this piece of video art that I really like. It's Television Delivers People from 1973 by Richard Serra and Carlota Faye Spoolman. You might recognize Richard Serra. He did those big metal sculptures. He's pretty cool. But he did this video art piece, and these are excerpts from it. But television delivers people to an advertiser. It's the consumer who is consumed. You are the product of TV. And the idea here is that if you are getting a free service from a private company, it means that you're being exploited. You're either being sold products or told who to vote for. It's like they want something from you. And that's what we're dealing with social media on like a much more sophisticated scale. But it's always been this way. And I just wanted to share some of the people who inspired me for this project. It's easy to sort of get down on the times that we live in with these problems, like I was explaining before. But these things have always existed, and there've always been people who were able to like overcome these negative aspects of society and create cool things. Here we have William Morris, who was a English textile designer and socialist during the Industrial Revolution. He's a central figure in the arts and crafts movement, which sort of morphed into Art Nouveau and then Art Deco and then modernism, which is the subway design. So there's sort of a direct line between William Morris and the subway. But I really like this quote from him. It's art made by the people for the people is a joy to the maker and the user. And he was a socialist, but also a successful business person. And I feel like in contemporary society, it's like people are like, oh, if you're like a socialist, you have to be poor. You can't even be rich or middle class. And he was able to reconcile these two things through the simple act of just paying his employees well and letting them do work that they liked to do, which seems pretty simple. But William Morris is really cool. Love his textile designs. And then over here we have Namjoon Paik, who's a Korean-American video artist who spent most of his life living in Soho back when artists could afford to live in Soho. He's a really cool guy. He's got this piece in Washington, D.C. It's this massive sculpture. It's a map of the United States, all the states outlined in neon, and they're all playing, they're all full of TVs that are playing clips that are like edited together, things associated with that state. So like, you know, Texas has cowboys and oil or whatever, but they're playing in these like crazy loops. And much like social media or like contemporary internet, the television back in the 60s, 70s, and 80s was also like a means of social control and influence over people. But Namjoon Paik took advertising and this sort of like ugly medium and he remixed it into something really cool that also made people think critically of the medium. And I really like this quote by him. Our life is half natural and half technological, half and half is good. You cannot deny that high tech is progress. We need it for jobs. Yet you make only high tech. You make war. So we must have strong human element to keep modesty and natural life. I think that's a really cool principle to live by. Like, you know, technology is not going anywhere. We can't go backwards, but we can use it in good ways. So thank you very much. I hope you guys visit My3DTrains and give me some feedback on, you know, how it works and what you want to see out of it. But there's my email and my LinkedIn and my GitHub. Yeah, thank you guys so much. Do you guys have any questions? What's up?
Seeing like all the missions and tracks just everywhere.
Yeah.
How detailed are you going to make your track map in this 3D environment? Like, is it going to be like Van Dragon's map?
Well, that I've built on top of his map.
Okay.
So ideally, I would make it as detailed as his map. It is a very time-consuming process to lay these tracks down. But it's just the type of thing that I need to like take like 3 or 4 days where I just like sit there and just drink coffee and add the map the tracks. But yeah, ideally I would make it as detailed as Andrew's map. Hey, what's up?
Yeah. In terms of the way you were doing your hello. In terms of the way you were doing your algorithm, 2 questions. One, was it possible to have multiple complexes along the same route? Does that happen in our system where like say the R train and the N train, you know, do they share multiple complexes along anyway, or is there some way that they have of encoding that does not happen? And 2, can you comment more about the north-south thing? Because it's interesting that every route seems to have north-south, but that's all they have.
Yeah. So the complexes, yeah, there would be multiple complexes along the routes. There's pretty much like tons of complexes in downtown Brooklyn and Midtown. So there'll definitely be multiple complexes along the route. And then the thing is, so with the GTFS data for north-south, it only provides north-south. but then in that, my database, which is made from a CSV file provided by the MTA, that has north direction label and south direction label. So if it says north, like what are some examples?
Because I know it gets really complex, like when the G, the F, and when the G and the F and the A and the C meet
Mhm.
at Hoyt,
Mhm.
between Hoyt, Bergen, and J,
Mhm.
how does that work in terms of your data?
Oh, well, it's like it's difficult. You sort of have to condense all the station info into the complexes. And that was like a tricky thing with the program. But and then there are like issues where it's like if you're leaving from a complex, you have to choose which platform you go to. Eventually with the algorithm, I want it to be like, okay, here are all the routes being served at this complex, like test everything out. But right now it's a little more manual. You have to like manually choose which platform you're gonna leave from. Yeah. But yeah, the direction labels, it's in the database, it'll be like north equals, outbound, or like south equals I don't know, Rockaway bound or something like that. So that's how you translate between those two.
I'm curious if I understood you. You're using the GTFS RT real time.
Mhm.
Why don't you use a static?
In what way, like a stat?
For you, well, for one thing, it doesn't change the way the real time does.
Mhm.
It's not updated.
Mhm.
Secondly, with regard to it, it's a lot easier to work with right off the bat. I mean,
Where's the stack? What would? Oh, the static, static data. Yeah, I guess so. But then it's like, if there's a reroute or something, then it.
well, by the way, the real time data won't help you because if I've been following that for quite a while.
Mhm.
If there is a reroute on the real time data, they just lose the train.
Okay. All right. But then the static data, would that be able to provide the like most up to date times for it? Like would the times be accurate or?
Well, it's updated about every 3 months or so. Pardon me, it's updated every day. There's a daily update that you can get,
Okay.
and it's good for a few days. And it's a lot easier to work with right off the bat.
No, I'll look into that. I think like for the algorithm, I sort of like built this like as I went along, learning new things about it. Now that I know more and looking back, I want to redesign it. But I think it'll have to be some sort of hybrid between like maybe the static data and the real time.
Well, one of the other problems is the MTA disobeys one of the requirements for the real-time data. There's no correspondence between the train ID between the two. There's supposed to be.
Oh, okay.
The other problem with the real-time data is the train ID is not unique. Trip ID is not unique because I'll give you the example that fooled me. For example, on the Flushing line, as you know, the train ID is based on the time and the route. They have 7 locals starting at the same time from both Main Street, the terminal, and 111th Street, where they have put-ins.
Okay. So there's going to be repeated.
That was an all-day bug for me to find.
Yeah. Well, that's good to know about. That definitely makes things difficult.
By the way, I love the idea of using Blender with the subway information. I guess I'm just curious about like the performance. Like, have you tried like pushing like a lot of polygons or rendering a high quality map, like, to export?
I haven't really. Right now, this one has like shadows, which is a little more processor intensive. It seems to run fine on mobile, even when the connection's not that good. But no, I haven't tried doing anything um, with like more polygons. I mean, there's a fair amount of polygons in the scene. But I think in the future, I'd like to do some cool like post-processing effects. Like what I'd really want to do is like when you have a route, I want the stations to kind of light up and glow and sort of like, you know, blink in the route. I think that would be really cool. So far it runs really well, and I haven't hit any sort of limitation on its performance, but I also haven't tried anything too crazy with it yet.
Are you providing cross sections and all data, I mean, all geometry in your models?
Sorry.
Cross sections of the tunnels, stations length,
Oh,
things like geometry that in the end is well, it's a 3D, as you say, it's 3D.
no,
was
I don't.
expecting-
Right now, I just have them as these cubes. There are people out there who have modeled the stations in 3D, and that's really cool. It'd be something that I'd love
Well,
to
yeah.
incorporate into it. But right now, I just it's so time consuming even just to lay these little cubes everywhere. I do want to make them a little more detailed, but I sort of feel like for now the cube works really well. But I want to add more detail to the map, but I don't know what is it? There's like 256 stations or something like that. So it's like there's a lot to work with there.
Would you be able to kind of work together with like a model, a 3D model for like other uses than just the location of the stations or your roads or something? You think that could be possible from your model to export it into other fields? Okay. Well, I work on metro systems as well. So I believe it's very interesting, the length, as you said, the 256 stations. So that could be useful for other type of models. I mean, in terms of physics and other ideas that, well, personally I have, you know, so it's feasible to transport it into like not just finding the roads, maybe for modeling the air velocities, things like that.
Yeah, I mean, honestly, like it's a data visualization project. So like whatever data is available, you can model with the process that I talked about. I'm not sure what one of the reasons I chose this was because the GTFS data is easily accessible and it's constantly changing, so it makes it a really interesting data set to work with. But yeah, I mean, anything's possible using this the system that I laid out, where you have the data and then you sort of use Python to make sense out of it, and then you create these components in 3D that that you can access with the data.
Okay, thank you.
Cool.
Model everything by hand.
Yes.
There really you didn't use the shape files provided by the FTA.
Yeah,
GTFS.
yeah, you know, it would have saved me a lot of time to use like Mapbox and the latitude longitude coordinates, and that would have saved a lot of time. It would have been harder to do the tracks then.
More detailed. Their route stuff is like more detailed than just connection routes. It's not quite track level detail.
Oh, really?
But like static feed.
Oh, no way.
They have.
I didn't know about that.
Yeah.
The shape files? Is
Yeah.
that okay? I always
It's
wondered
like
what
shape
shape files
files.
was. That's like the shapes of the tracks?
Yeah.
Really?
Well, it's not the tracks. It's like slightly higher level than that, but like Google and all of the other places that are displaying that use their routing.
Ah, okay, cool.
So it would help you like, and it's because it's tied in, like you can just automate it with Python.
Yeah.
You don't have to do the hand naming.
Yeah. Okay, that's very good to know about. I wish I knew about that earlier.
Shape files are on the static GTFS.
Okay, cool.